So the height of the AVL tree is always now O log n, where n is the number of nodes in the tree, as compared to the worst case rotation that we had seen in case of binary search tree. So here you can see the time complexity of AVL insert remains same as binary insert, which is OH, where H is of the height of the tree, that is O log of n. So the rotation operations take constant time, as only a few pointers are being changed there. So updating the height and getting the balance factor also take a constant time. So it remains the same, but we are able to improve the performance. So here let us see one example. So let us create one AVL tree, right? So let us say we have received, as I told you, that input data can be in any of the orders. Can you first create, all of you create a binary search tree using this input data? Yes, please. And tell me whether it is balanced or unbalanced. Okay, anyway, I'll just show you. So whenever we create a tree using the received input, that is the input that we have received is this. So the tree that we create, the binary search tree, we know first element, it becomes the child or root node, and then we start creating the inserting the other nodes. So here you can see 17, which is greater than 14, it comes on the right. Then 11 is less than 14, it becomes the left node. Now the next element, that is 7, that is will become the left node because it is less. Similarly, we are going to create the complete tree. Now from this tree you can see this is not a balanced tree, right? So since it is not a height balanced tree, so its time complexity, searching time complexity may be very high, right? So in order to resolve this problem, what do? We have to make it balanced. Now tell me, which particular rotation will help us in balancing this tree?
L.
Which rotation?
Left.
Left rotation. Think over it.
Left.
ये जो अनबैलेंस्ड इज लेफ्ट ऑफ लेफ्ट, तो क्या करेंगे हम? ऑपोजिट डायरेक्शन में उसको रोटेट करेंगे. अगर लेफ्ट ऑफ लेफ्ट जो सब ट्री है दैट इज अनबैलेंस्ड, टोटली लेफ्ट हो गया. आप याद रखो कि दोनों ही लेफ्ट है, तो उस केस में वी विल बी ऑलवेज परफॉर्मिंग द राइट रोटेशन. राइट रोटेशन करने से क्या होगा? 7 will become the child node of 14 and 11 will become the right child node of the 7, like this. Got it? Yes? समझ में आया कि नहीं आया?
Yes, ma'am.
Shall I proceed?
Yes, ma'am.
Okay. Now let us, after balance, see what we have done is, after creating this one, because now what we are trying to create, we are trying to create a AVL tree. So as soon as the tree becomes unbalanced, see before this, before the insertion of 4, the tree was balanced. So we have not done anything. But as soon as we insert 4, the tree becomes unbalanced. So that means after every insertion, we have to check whether the tree is balanced or not. So if the tree is not balanced, what we will do? We will first apply the rotation, we will make it balanced, and after that we will be doing the further insertions. That's what we do, what we have done. So it is unbalanced, we apply the rotation, now the tree is again balanced. So here you can see the right subtree and the left subtree both have the same height, right? And then what do? We do the further insertions. So the 13 comes over here. Now after the insertion of the 13, let us try to insert 12. Where it will come? Where the node 12 will come?
Ma'am, left of 11.
Left of 11. Wait, why it is coming? Wait.
Ma'am, no, ma'am, sorry, left of 13.
ठीक है?
Yes,
so
ma'am.
now we can see the tree has again become unbalanced after this insertion. Now tell me what we will do. Which rotation we will apply? Yes. Which rotation we are going to apply?
Left rotation.
Only left. Single rotation or double rotation we will need.
Ma'am, double rotation.
Always remember the scenarios. So what we have to do when it is totally left unbalanced, only one rotation required. When it is totally right unbalanced, only one rotation required. But whenever it is right left or left right, we require double rotations. Okay, so now you just remember those cases. So in which case we will be applying the left to right or right to left. So here what we will do, we will first apply the right rotation. So when we apply the right rotation, it becomes 11, 12, 13. Now we know this is completely right. So now we can apply the left rotation over here. And when we apply the left rotation over here, 12 becomes the child of, you can say the 11 will become the left child of 12. So now the tree becomes a height balanced tree. Clear this thing? So what, when we are applying the rotations, you have to remember what kind of operations we are going to apply, right? So that means you have to first understand the current scenario, whether it is left, completely left unbalanced or completely right unbalanced, or it is left right or right to left accordingly. Now where we are going to insert the 8th?
Left rotation.
Hmm?
Left rotation.
लेफ्ट रोटेशन किस नोड पे अप्लाई करेंगे हम?
7 वाले नोड पे, 7, 12 और 11 वाले.
So let us see, right? हमने 12 पे अप्लाई किया. देखो वापस देखो इसे. जब हमने 12 पे अप्लाई किया, हमने राइट रोटेशन अप्लाई किया है. राइट रोटेशन अप्लाई करते ही 11 नोड जो है दैट बिकम्स अ पेरेंट ऑफ द 12. सो हियर यू अगेन सी दिस. Sorry, पीछे चले गए. Right? So now again it is unbalanced. Then what do? We again apply the rotation and then we insert. See that we are applying this insertion because we cannot repeat the same thing and get back to it. So we apply the rotation over here and we place the 8 at the appropriate position. So here you can see the complete rotation, the complete tree has changed.